Hi Year 11, this is our second lesson for the topic of differentiation, and this is for the International Baccalaureate course Analysis and Approaches, and it is applicable to the higher level course and the standard level course. Last lesson was an introduction to differentiation. In this lesson we're going to look at the rules of differentiation. So let's start by looking at brackets. If we want to differentiate y is equal to 2x minus 1 all squared with respect to x, then currently our only option is to expand and then differentiate. So expanding is going to give us y is equal to 4x squared minus 4x plus 1, and differentiating term by term, we're going to get 8x take away 4. Now that's all very well, but it's going to prove difficult if we're asked a question like y is equal to 2x minus 1 all to the power of 7. And so the first of our rules that we're going to learn is called the chain rule. It's also called function of a function rule, and we use it when we have a function embedded inside another function. And that's what we have here. So y equals capital X squared is the outside function, and inside we've got 2x minus 1. So let's recall composite functions, f of g of x. If f of x is equal to x squared and g of x is equal to 2x minus 1, write f of g of x. So remember, we can write it like this, and that means replace x with g of x. So instead of x squared, we're going to put 2x minus 1 in where the x is, which of course gives us 2x minus 1 all squared. So this is a function inside another function. So here's the chain rule. If we want to find the derivative with respect to x of a composite function, then we differentiate the outside function, so we find f dashed of g of x, we leave that inside function alone, and then we multiply by the differentiation of the inside function. Now the proof is really easy. Let's consider y is equal to f of g of x, which is a composite function. Now we're going to let u equal g of x so that y is equal to f of u. Now have a look at this. This is why it's called the chain rule, because it's kind of like a chain. We've got dy dx is equal to dy du times du dx. Can you see that that's true? Because the du's could cancel out. Now dy du, well, that's equal to f dashed of u, and du dx is equal to g dashed of x. And then let's just replace this u with g of x, and there's the chain rule. Let's differentiate y is equal to 2x minus 1 all squared. So the outside function is a power rule. The inside function is two power rules, isn't it? So we're going to go dy dx is equal to, bring the 2 down, multiply by 2x minus 1, don't change it, all to the power of 1, times by the derivative of the inside function, which is 2. And let's just tidy that up. There's our answer. How about this one? Y is equal to 2x minus 1 all to the power of 7. The 7 comes down, leave the inside function alone, to the power of 6, times by the derivative of the inside function, which is 2. Tidy it up. 7 times 2 is 14. So here's a common mistake. What's happened here? If we want to find the derivative of 3x squared plus 1 all to the power of 5, well, the 5's come down and we've reduced the power by 4, but we should have left this 3x squared plus 1 alone. Instead, it's been differentiated. So what should it be? I'll leave you to answer that question. Let's try a harder question. Differentiate y is equal to the square root of 1 minus x squared. Now, like all questions involving square roots, we have to change from radical form into index form before we can do anything. So y is equal to 1 minus x squared all to the power of a half. Okay, we bring the half down, leave that inside function alone, reduce a half by 1, then multiply by the derivative of the inside function. So this is what we end up with. So the half comes down, see? 1 minus x squared to the power of negative half multiplied by negative 2x. Now, tidying that up, we end up with negative and then 1 minus x squared all to the power of negative half. Now, we can leave it like this, it's no problem at all, or we can put it back the way we found it. Now, a graphics display calculator, like the TI Inspire, will actually calculate the numerical derivative at a certain point. So you would go and open up a calculator page and you would go to Menu, then Calculus, and Numerical Derivative at a point. And you will end up with this screen. So our variable is x. You have to put in a value, so it's not going to work out just a derivative for you. So in this case, I'm going to put in 0, x is 0, and I'm going to choose first derivative. And then I'm going to end up with this on my screen, and this is where I'm going to put the function. So let's just make something up. Let's say 3x minus 1 all squared. So I'm doing the derivative of this at the point x is equal to 0, and the answer is negative 6. You can also find the second derivative. Now, we haven't covered that yet, but if you wanted to, when you get this dialog box here, instead of choosing first derivative, you choose second derivative. You've still got to put in a value for x. And there we have the second derivative of 3x minus 1 all squared at the point x is equal to 0, and it's equal to 18. Let's move on. So we talked about this last lesson. How do we differentiate y is equal to 2x minus 1 in brackets multiplied by x squared plus 2? Currently, our only option is to expand that out. We end up with y is equal to 2x cubed plus 4x minus x squared minus 2, and we differentiate term by term. So here's our second rule that we're going to learn this lesson. It's called the product rule, and it's for when we have two functions multiplied together. They both have to be functions of the same variable. In this case, I'm going to say they're functions of x. And this is how it goes. So the derivative of y with respect to x is equal to the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And in your formula booklet, it's written like this. So here's the example we did before. Differentiate y is equal to 2x minus 1 in brackets multiplied by x squared plus 2 in brackets. We'll start by letting u equal 2x minus 1 and v equal x squared plus 2. Do the derivatives. U dashed is equal to 2, v dashed is equal to 2x. Now let's construct the product rule. It is u multiplied by v dashed plus v multiplied by u dashed, and don't forget your brackets. And expanding through and collecting like terms, the derivative is equal to 6x squared minus 2x plus 4. Our second example, differentiate y is equal to x squared sine x. So again, I'm going to split that up. I'm going to let u equal x squared and v equal sine x. Now I'm jumping the gun a little here because we haven't done derivatives of trig functions, but the derivative of sine x is cos x. And this is an example where we can't do this any other way but to use the product rule. We can't expand it. So it's a nice example for you to see. So let's do the derivatives. U dashed is 2x, v dashed is cos x. And constructing the product rule, we're going to get x squared times cos x plus sine x times 2x. And tidying it up, our derivative is x squared cos x plus 2x sine x. And we can combine the two rules. Let's have a look at these two questions. They're subtly different. The first one is a product, but this part here involves a chain rule. Now, I'd always encourage you to write this out so that you sort of get your thinking clear. So u will be equal to 2x and v will be equal to x squared minus 1 all to the power of 5. And u dashed would be equal to 2. V dashed, now we're doing our chain rule, is 5x squared minus 1 to the power of 4 times by the derivative of the inside function, which is 2x. And take the time to tidy this up. All right, and then construct your product rule. Now this one over on the right is a little bit different. Here we've got a product inside a chain rule. And so we're going to start this one a little bit differently. I'm going to start by writing it in index form. So we've got x squared minus 3 times sine x all to the power of a half. And so y dashed would be equal to a half. I'm doing the chain rule first. Then x squared minus 3 sine x all to the power of negative a half. And then I want to times by the derivative of that inside function. And that's where your product rule will come into play. Now, I'm going to leave you to finish those two questions off. Okay, let's move on to quotients. Recall that if a fraction is top-heavy, we can split it into two and differentiate term by term. So if we've got the derivative of x squared minus 1 all over x, we can rewrite that as d dx of x minus x to the power of negative 1, and then differentiate term by term. But we can't split a bottom-heavy fraction like this. Which brings us to our final rule, the quotient rule. We use the quotient rule whenever we have a function divided by another function. And for f of x is equal to u divided by v, and u and v both have to be functions of x, then the derivative will be v multiplied by u dashed minus u multiplied by v dashed all over v squared. You can see how it's written here in your formula booklet. So let's look at some examples. Find the derivative of y is equal to x squared plus 5 all over 1 minus 2x. So we'll start, like we do with the product rule, with saying what u is and what v is. So u is going to be equal to x squared plus 5, v is equal to 1 minus 2x. U dashed is 2x, v dashed is negative 2. And now let's construct the quotient rule. So it is going to be v, make sure you put that in brackets, it's got two terms, multiplied by u dashed minus u multiplied by v dashed all over v squared. And all we're going to do here is tidy up the numerator. We're not going to expand the denominator. And by expanding, we get 2x minus 4x squared plus 2x squared plus 10 on the numerator. And collecting like terms, we end up with negative 2x squared plus 2x plus 10 all over 1 minus 2x all squared. And here's example 2. Find the derivative with respect to x of x divided by the square root of 2x plus 1. So u will equal x and v will equal the square root of 2x plus 1, which of course I can write in index form. U dashed is equal to 1. And here we have a chain rule. So v dashed will be bring the half down, multiplied by 2x plus 1 to the power of negative a half, multiplied by the derivative of the inside function, which is 2. And take the time to tidy this up. A half times 2 is 1. Now let's construct the quotient rule. It is v multiplied by u dashed. Take away u multiplied by v dashed divided by v squared. We've got a bit of a mess here because we've got double-decker fractions. This is really on the denominator. Can you see that negative there? So what I'm going to do is take this 1 on 2x minus 1 out the front and then tidy up that numerator like this. And I've converted back to radical form. Can you see that? So instead of index form here, I've written that as the square root of 2x plus 1. And this is going to be take away x divided by the square root of 2x plus 1. Now, it's probably correct at this point, but I'm just going to join this into, make it into one fraction like this. And tidying it up, we end up with x plus 1 divided by 2x plus 1 in brackets multiplied by the square root of 2x plus 1. Okie doke, that's our lesson on the rules of differentiation. In our next lesson, we're going to look at how we differentiate exponential and logarithmic functions.